All right, here is the second video. So now we're going to actually fill in this unit circle with the radians and the degrees and the coordinates. Whoops. So I'm going to make this a little bit smaller so I can fit it all on the screen. So this unit circle is going to become a very important tool for you for a vast majority of this course. So we're going to fill in this unit circle. It is something that you will soon be memorizing or at least understanding the points for. So I'm going to start here. Here is our center of the origin, or center at the origin rather. And we're going to talk about what each of these coordinates mean. So we focused on these first three on the beginning of the last video that you watched. And so what I'm going to do is I'm going to copy those coordinates in here. So the first one we know was 30 degrees. Then we did 45 degrees and then 60 degrees. I'm going to go ahead and put the radian version. So remember, 30 degrees are multiples of 6, so pi 6. 45 degrees are multiples of, they're multiples of 45, but they represent the fourths, so pi fourths. And 60 degrees, when you have multiples of 60, you're dealing with thirds, so pi thirds. Now the coordinates for the 30 degree, if we were to go back to what we did in the last video, they were radical 3 over 2, 1/2. For 45 degrees, if we go to our triangle for the 45 degrees, that's the one where the x and y were the same value, so radical 2 over 2. And for 60 degrees, it was like the 30 degrees, but just switched around. So 1/2 radical 3 over 2. Now I'm not going to fill in the quadrant values yet because I want to use these three sets to illustrate what happens in quadrant 2 and quadrant 3 and quadrant 4. So everything else is going to be a reflection of these three sets of coordinates. Okay, so if I go to the reflection of 60 degrees, that would be 120 degrees. That would be another group of 60, so it would be 2 pi thirds. And the coordinates, the x coordinate, so we're moving from the positive x to the negative x, so it'll be negative 1/2 positive radical 3 over 2. Okay. 45 degrees, the mirror image of that is 135 degrees. So 135 degrees, when we look at that, that's, let's see, so 1/4 up here would have been 2/4, so this is 3/4 of the way around to pi. I will label pi on here, 180 degrees. But you kind of need to understand the relationship of pi. All right, the coordinates for that, you just change the x coordinate to its opposite sign. For 30 degrees, its mirror image is 150 degrees. And so we have pi 6, so it takes groups of 1/6, so 30, 60, this will be 90 degrees, 120, 150. So it's 5 groups of 30, so 5, 6. So each group of 30 is 1/6. Coordinates for that, you just have negative radical 3 over 2, 1/2. When we go beyond this, I just want you to notice a pattern with the degrees real quick. So these bigger gaps, like right here, are 30-degree gaps. Okay, and these smaller little bits are 15-degree gaps. So if you're kind of thinking of the pattern with these angles, you could also think like that. It could also give you insight as to what fraction you should be using for your radian measure. All right, so continuing on, if we go ahead and label out the degrees, we have a big gap here, so that's 30 degrees, so that makes 210. Then I see a small gap, so 15, and a small gap again, and a bigger gap, and a bigger gap, and a smaller gap, and a smaller gap, and a bigger gap. By the way, 360 degrees is the same as 0 degrees. Remember when we talked about coterminal angles, that's where that would come in. For 210, so we've gone another 1/6 of the way. So remember, pi is 6 pi 6, so this becomes 7 pi 6. If we want to go ahead and look at all the multiples of 6 first, 240 would be 8 pi 6. But it's also a group of 60, so it's 4 groups of 60, so 4 pi thirds. 270 would be another 1/6 of the way, so it'd be another third of the way there, 5 pi thirds. It would be another 6, so it would end up being 9 pi 6, which would be, not 5 pi thirds, whoops, 3 pi halves. Oops, sorry about that. Let's see, 300, that's going to be 5 groups of the 60 degrees. That's where the 5 pi thirds needed to be. 330 is going to be a whole bunch of groups of 30. It's going to be 11 groups of 30, so 11 pi 6. And then when you get to 360, that's going to be, 360, it's going around twice, so 2 groups of pi. Filling in the ones for the quarter ways, so we have 1/4 here. This would be 2/4 or a half, so pi halves. We already got the 3 pi fourths. This one will be 4/4. So we have 5 pi fourths here. This one was 6 pi fourths, which makes 3 pi halves. This would be 7 pi fourths. Okay? Sometimes I think of the fourths ones as the ones that are kind of in the middle of each quadrant. So that can sometimes help. All right, so now that we have all of that, now let's just, this would be 0. Now for the rest of the coordinates. For the rest of the coordinates, you could literally just take the coordinates that you had listed and just keep doing reflections. In the third quadrant, everything is negative. So here we'll have negative radical 3 over 2, negative 1/2, negative radical 2 over 2, negative radical 2 over 2, negative 1/2, negative radical 3 over 2. And then over here, we'll have positive x coordinates, so 1/2, negative radical 3 over 2, radical 2 over 2, negative radical 2 over 2. And here we'll have negative radical 3 over, not negative, radical 3 over 2, negative 1/2. The last thing to consider are the angles at the quadrants, which will be pretty easy because, the axes, not the quadrants, the axes. Remember the radius length is 1. Up here, the y coordinate is 1. On the left side here, -1, 0. And down here, 0, -1. So what we have here is the complete unit circle. And we're going to talk a lot more about how to use this unit circle. So if you're feeling a little confused about it right now, that's okay. What we're going to do to start is we're just going to practice understanding the unit circle, knowing where these different measurements go, and ways to remember how to navigate the unit circle. Future lessons, we'll talk about using the unit circle to actually do trig problems. Okay, so that's where we're going to end things today.